Hello friends, welcome back to our channel Chemistry with Coffee. Let's begin with today's topic. This week we are going to see what's going on in the liquid extraction lab experiment. Suppose while you are working in the lab, you have accidentally broken two chemical bottles, benzyl benzoate and glucose, and ended up with its mixture. Do you think you can separate them? Before thinking about their separation, let's have a look at the principle of liquid extraction. Its principle is very simple and clear, like dissolves like. More elaborately, polar compounds dissolve in polar solvents, same way non-polar compounds dissolve in non-polar solvents. Before you begin, pick up a clean and dry separatory funnel and secure it with clamps to a metal stand as shown in the image. Then make a solution out of benzyl benzoate and glucose mixture and deionized water. Place this solution in the separatory funnel from the top opening. Add an extracting solvent, for example diethyl ether, which is non-polar, into the same separatory funnel and close it with a stopper. Now we have two immiscible liquids in the funnel. Shake the funnel in a horizontal position by frequently venting or releasing the pressure formed by opening the stopcock of the lower tip. While doing it, position it slightly upwards and after releasing the pressure, close the stopcock. The vapor pressure is developed inside the funnel due to the heat generated by vigorous shaking. During these shakings, both the polar and non-polar compounds will have a chance to interact with both the liquids and then dissolve. That is, polar compounds will go into the polar solvent while non-polar compounds will dissolve in the non-polar solvent. Place the funnel back onto the metal stand and secure it with clamps. Allow it a few minutes for the immiscible liquids to nicely form layers. Sometimes it is confusing to identify the layers. We can solve it by using their density values. The density of diethyl ether is 0.7 gram per ml and water 1 gram per ml. Our common sense tells us that less dense solvent float on the high dense solvent. Here the light top layer is ether and heavy bottom layer is water. Collect the lower water layer into a clean and dry beaker from the lower opening. The ether layer is poured into another beaker using top opening of the funnel and label it as ether 1. Then place the previous water layer back into the separatory funnel along with a fresh ether layer. Shake the funnel, vent the pressure, allow it to settle to form layers. Do these 3 jobs for 2 more times. Collect the ether layers in separate beakers and label them as ether 2 and ether 3. Now we have extracted most of the benzyl benzoate from the mixture into the ether. Combine the 3 batches of ether layers and evaporate the ether solvent using simple distillation. Or you can take the help of rotatory evaporator, which can do the job more quickly. If you haven't watched our simple distillation video, please go back to our channel to watch it. This is just one of the applications of liquid extraction. Liquid extraction is more frequently used to extract the non-polar compounds from salts in the reaction mixture of an organic reaction. More about how to start a reaction till the product separation will be discussed in one of the upcoming videos. Okay, let's revise what we have learned today. First, polar solutes dissolve in polar solvents. Second, non-polar solutes dissolve in non-polar solvents. Third, make sure you release the pressure formed in the separatory funnel while shaking to avoid explosion. Fourth, don't throw any of the layers until you have confirmed the sample. Fifth, make sure you follow safety protocols in the laboratory. Don't forget to wear apron, goggles, gloves, etc. for your and others' protection. Okay, that's it for today guys. Thank you very much for watching. If you have any questions, please don't hesitate to ask them in the comment section below. See you all next week with one more lab technique. Don't miss out our upcoming videos. Please like us. For more updates, make sure you hit the subscribe button.